We're the PULSTAR pals. I'm Will.
I'm Jake.
I'm Donald.
And we have how not to build a nuclear probe. So the goal of the project was to build a probe that will detect blue light, which is Cherenkov radiation, that is produced by the PULSTAR reactor on campus, so that we can determine the amount of power being generated by the reactor. A little bit of background on the reactor. It's a 1 megawatt reactor on North Campus. They sent out an application recently to be able to operate at 2 megawatts. It can generate that amount of power, but it's almost only used for research on campus.
All right, so here we have a little background on what Cherenkov radiation is, and it's light produced when particles move through a medium, in this case water, when it's going faster than the speed of light. And this was discovered by Mr. Cherenkov in 1934, and he got a Nobel Prize for it because he's cool. And then this is what the radiation looks like. You get this really cool blue light. That's either a continuous glow or a flash. And our background here is said light, because yeah.
So for the probe, it has to be able to operate in the blue spectrum. It has to produce some sort of electrical signal based on the light it detects. It has to be entirely PVC piping. It has to be waterproof so that your sensors don't get messed up. And with all FEDD projects, it has to be under $40. So our timeline, we first did research on the radiation in the reactor itself, and then we did research on what sort of light sensors we would use and how we would wire them. We then gathered all of our materials. We built a small prototype to test waterproofing, and then we built our final probe and wired all of our photodiodes, and then we attended our test date, interpreted the data, and then most recently we attended the actual FEDD presentation day. So we rented a multimeter from the engineering supply shop. We used PVC pipe and caulk to waterproof it. We were going to use electrical tape as part of our waterproofing, but we'll talk about that a bit later. We used 10 feet of 2-inch diameter PVC pipe, a 2-inch connector, and a trap adapter at the end that held our plexiglass lens. Our wiring was 14G solid copper wire. We had some stranded copper wire at the photodiodes, but the wire that landed through the tube was solid. And these are our photodiodes. They're from Orsam. They're a company that makes photodiodes.
Alright, so the initial construction, we built a test probe, and it was like 2 feet long, and we had their trap adapter with our plexiglass lens. It was really annoying to make the plexiglass lens. It was fun, enjoyable, I loved it. And we tested it to see if the electrical tape and the caulk would just waterproof it as it was, but it turned out the electrical tape didn't work out as we thought it would and actually made it not waterproof whatsoever. And so we decided to scrap the idea of using electrical tape and just use a bunch of caulk to waterproof it in general. So that was the product. You can see me and Andrew in the corner just ringing it up to the top. William's filming it. And yeah, we tied it to a pipe. It was fun. After this, we spray painted it blue just, for the memes, but we couldn't actually spray paint it before we tested it because paint and the reactor don't really go together.
So on our actual test date, this was the data we got. They gave us a baseline reading from our probe when the reactor was off, and then they told us when the reactor was at 100 kilowatts, 300 kilowatts, and 500 kilowatts, and we took readings, and then we would make a graph and interpret what the mystery level would be. So on test date, our probe did not actually work. So these are the data points that we received, which for us did actually make a very nice looking graph. And using the equation for the line that we got, we calculated that the mystery power level was exactly 300 kilowatts when we know that it was actually 350 kilowatts. So our percent error was 14.3%, which isn't as bad as we thought it was going to be for a probe that didn't work. But the issue was that on test date, we know it wasn't a waterproofing issue because it detected light when they turned the overhead lights back on. Just when they turned the overhead lights off, the photodiodes weren't able to pick up the blue light coming off of the reactor because it's much weaker. And since we had our photodiodes wired in parallel, the circuit would just show us the voltage being allowed through by whichever photodiode is detecting the least light. So one of them must not have been detecting any light, and our circuit was reading basically 0 as a result. So our big change was going to be that we would either wire it in series next time, because voltage would be additive in series, so that it wouldn't have as many issues, because if one photodiode wasn't picking up the light, it wouldn't matter, or we could just secure our photodiodes better, and that would have also fixed the problem.
So when we got to FEDD, we tried. You know, we had a great presentation, but as we've showcased, our probe didn't work as well as we hoped. And so here we have some very nice pictures that really just encompass how we felt during and after FEDD.
We did get an honorable mention, surprisingly.
So that's pretty great.
Our advice for next year's freshmen is to build a probe that works. The circuit is a bigger issue than you would think it would be. We were really worried about waterproofing, but it turns out the biggest issue was the circuit. Also, take more pictures. We did not take very many pictures during the process. And relax, because everybody at FEDD was actually very casual, and it wasn't as stressful as we thought it was going to be. That's all.
Thanks.
Bye, guys.